Good morning or afternoon. We are going to learn about eclipses today, solar and lunar eclipses. So far in this unit, we have talked about the reasons for the seasons, the fact that the Earth is tilted as it's revolving around the sun, gives us different angles, more direct or indirect to the sun's energy, making it different seasons in different places of the world. We have talked about moon phases. And we have learned that depending on the positioning of the moon in relation to the Earth and the sun, the moon will only reflect so much of the sun's light to our view. In reality, it's always got half of the sun's surface is illuminated and the other half is dark because it's facing away. But to us, we only see certain angles of that. So we're getting these 8 distinct moon phases. So today we're going to add in solar eclipses. So we're still talking about the same objects, the moon, the sun, and the Earth. So eclipses occur because of the periodic alignment of the sun, the Earth, and the moon. So every so often, these 3 objects that normally are just a little above and below each other align perfectly. And that's going to cause an eclipse. The moon's orbit is tilted about 5 degrees above or below the Earth's orbit. So normally the moon is slightly above us or below us as it's orbiting around us, as it's revolving around us. And because of that, we don't get eclipses like every month. So some may go, well, what about a full moon or a new moon? Those are the perfect alignments for things to block each other and cause an eclipse. But normally the moon is just a little bit above or a little bit below us, so we don't get that perfect alignment. So we don't experience eclipses every month. So here we can see in the first picture what a lunar eclipse looks like. So if you notice, we start with a full moon. And it makes sense because if it were any other phase of the moon where there's already pieces that seem to be missing because they're not illuminated by the sun's light, it would make it more difficult for us to even tell that the eclipse occurred. So not only does the alignment have to work out where the Earth is actually blocking its own view of the moon, but it's a full moon. So it makes it super obvious. Also, it's the correct alignment. So this occurs during a full moon. Sometimes we'll notice that the lunar eclipse, it gets really dark, but it takes on like a reddish hue, like it almost looks kind of a red color. And that other diagram over here kind of explains what's happening. So when the sun's light is blocked, different like ranges of what we see, so the electromagnetic spectrum, our eyes can only look at one particular part, and that's the visible light spectrum. So certain like rays in that spectrum are blocked, so things will turn a little more reddish to us, and it's because that red light is what's coming through because the bluish side of the spectrum is being blocked for us. So in a lunar eclipse happens when the Earth moves between the sun and the moon. So then if we're thinking of these 3 objects, the sun, the Earth, and the moon, the Earth's in the middle. So I always like to think of like ways to help me remember. So I always think of the order of the celestial objects here, sun, Earth, moon, kind of helps me like SEM. Okay, so SEM. Lunar eclipses only occur during a full moon, like I said before, because it is during that time normally that the moon is slightly above the Earth. So the sun's rays would normally hit its full surface, and that would look like a full moon to us. But in this particular occurrence, everything is perfectly aligned. So the Earth is actually blocking its own view of the moon because it's blocking the sun's light from getting to the moon. Now, a lunar eclipse takes about an hour, a few hours at the most to occur. And it happens a couple of times a year, not necessarily where we live, but all over the world, it's occurring several times a year. At this time, you could drag and drop your labels to label the sun, the Earth, the moon. So the sun, the Earth, the moon. The umbra, which we're about to talk about, the darkest part of the shadow that's being cast by the object that's blocking the light, and then the penumbras, which are the surrounding areas of shadow that are less dark. So we'll learn that a total lunar eclipse is viewable from anywhere on Earth that's within the umbra. Well, if you look, it's most of that side of the Earth that's experiencing the eclipse. So really, when there's a total lunar eclipse, most places on Earth get to experience it that night. If you're at the very, very top, though, or the very, very bottom, then you may only get to see a partial eclipse because it's the penumbra that you are able to view, sort of like not a full shadow that's being cast over the moon. So here we can see the moon is moving around the Earth as it does. And right in here, when this alignment occurs perfectly within the umbra, the moon is being blocked by the Earth from getting any of the sun's light. So it has to be this perfect alignment. If you are within the umbra, which pretty much most of the Earth is, you'll see a total lunar eclipse. If you are at the very, very North Pole, South Pole, you may only get to see a partial eclipse because you're within the penumbra, a less dark portion of shadow that's being cast by the Earth. In a solar eclipse, you have the moon that is the middle object here. So solar eclipses obviously occur during the day. So we can see we're in the day portion of right here that looks light. And then the moon is orbiting, and in this perfect alignment will block our view of the sun. Now we know the sun is huge compared to the moon, but the moon's really close to us and the sun's super far away. So for those few moments, it's just enough to cover up the corona. Well, everything but the corona. So we still see like sometimes like this little outline that's called the corona, which I know no one wants to hear that word right now, but that's what it's called. Corona means crown, right? So we're looking at like this little crown or halo of light that's left in a total solar eclipse. So because of the alignment, because the moon is between the sun and the Earth, that night we should see a new moon phase because that's the alignment for a new moon. It's happening where the moon is moving a little earlier into that alignment perfectly in a straight line. And it's blocking our view of the sun. Now, this only takes a few moments. It's done within a few minutes. It doesn't last very long. Most of you guys will remember the total solar eclipse from 2017. Probably had to buy little glasses or made something with a cereal box and poked a hole so you could see through the shadow. But they only last for, just a few minutes, really. So solar eclipses happen when the moon moves between the Earth and the sun. Solar eclipses occur during a new moon phase. And the only reason that's important to know, because obviously a solar eclipse is in the daytime, but it helps us remember the positioning because we should know that a new moon is nearest to the sun. So if I always remember solar eclipses are like new moons, then I remember the order is sun, moon, earth. So SME instead of SEM, SEM, this is SME, SME. So go ahead and label your sun, your moon, your earth. And now let's label that umbra and penumbra. I think your penumbras are done for you. Notice the umbra. This is the umbra right here. That teeny tiny little area on Earth. When you have a total solar eclipse, it is a very small portion of the Earth that actually gets to experience it, which is why it can be 30 years before an area like North America may not see one again for many, many years. And they might. It just all, of course, just depends on alignments. But you can go a whole lifetime and only ever see a solar eclipse one time because of the way that the alignment has to occur and the locations of the Earth that will be within that portion at that time. Now, a partial solar eclipse can be experienced by many people because look at how large the penumbra is. So pretty much everyone in a given area might be able to see some portion of that solar eclipse, but a total solar eclipse is only viewable in this teeny tiny little umbra right here. Because remember, it's not this side, because it's the moon that's blocking the Earth's view. It's here, tiny little portion. So here you can see how small that is. Look at that umbra. From Earth, only whatever area is in this little section gets to see the total eclipse, and the other surrounding sections where the shadow is less dark would see a partial solar eclipse, which is cool, but not as cool as a total solar eclipse. So more people on Earth experience a total lunar eclipse when they occur. Only a small portion of the Earth experiences a total solar eclipse when they occur. So if we're learning these words, umbra and penumbra, umbra is the darkest part of the shadow. That's where people will see a total eclipse. Penumbra is the lighter part of the shadow where you would see a partial eclipse. So in this first picture, it's kind of just modeling it with a flashlight and what looks like a baseball, maybe a tennis ball. But the idea is that that sun is the light, and this right here, in this case, could be whichever. It's the moon or the earth. It could be any of them. But the part where the actual item is, the shadow it casts, is the darkest part. That's the umbra. So when the earth is the object viewing, blocking in a lunar eclipse, well, the earth is much bigger, so it's going to have a much bigger umbra. When it's the moon that's blocking our view of the sun, the moon is much smaller. It's going to have a smaller umbra. The surrounding areas are less dark, and that's where you get your partial eclipses. So what are some things that they have in common and help us remember how they're different? So let's start with the middle portion. Both solar and lunar eclipses occur when one space object or celestial object moves into the shadow of another, right? We're blocking the view of Earth of a certain object, whether it's the sun or the moon. In the case of a lunar eclipse where the Earth is blocking our own view of the moon that night, of the full moon that night, the moon passes through the Earth's shadow. Lunar eclipses can only occur during a full moon. Lunar eclipses occur about twice a year everywhere on Earth, and they last for about an hour. Solar eclipses are when the sun's light is blocked by the moon, a much smaller object. Solar eclipses can only happen during a new moon phase just because of the positioning. The moon has to be between the sun and the earth, and that night would be a new moon. Solar eclipses do not happen often because the umbra is so small. The shadow that the moon casts on the portion of the earth that gets to experience the eclipse is so much smaller that it just doesn't occur as often as a lunar eclipse does because the earth's shadow is so much bigger. And solar eclipses only last for a few minutes because, again, the moon is a much smaller object. And as it's moving, it will, quickly start to uncover the sun, which is much, much larger than it.